All right, guys. Today we're going to continue to talk about multiplying binomials, but particularly we're going to go into special cases. Special cases like perfect square trinomials and difference of squares. And you may be saying, well, what is a perfect square trinomial? Well, if we remember from before, a perfect square is like 16, right? 16 is a perfect square because we can write it as 4 times 4, right? Which is 4 squared. So this is a perfect square. All right. 4 is a perfect square because it can be written as 2 times 2 or 2 squared, right? So these are both examples. 4 and 16 are examples of perfect squares, right? These are perfect squares, right? So with this in mind, a perfect square trinomial is when we have a binomial, right? So let's say we have x plus 3 times x plus 3. Then we can write this as x plus 3 quantity squared. That's a perfect square. Why do we call it a perfect square trinomial? Because if we were to multiply this out by most people's favorite method, box, then we get which is x squared plus 6x plus 9. This is called a perfect square trinomial. Trinomial because it's 3 terms, right? And it's a perfect square because it can be written as x plus 3, quantity squared. And we say quantity squared because x plus 3 is grouped together. All right, so now that we have the little backdrop here, let's go into some actual examples. All right, we have here a minus b quantity squared is the same as a minus b times a minus b, which if we multiply it out, it gives us this result. Now, feel free to note that when we have this first example here, x minus 2 quantity squared, we can rewrite it as x minus 2 times x minus 2. And then you use your favorite method to multiply this out, whether that be FOIL, double distribution, or box method, right? You could do it that way. Or you could use this formula right here, right? You could use this formula right here. All right. A squared minus 2ab plus b squared. You may be wondering, well, what does that mean? Well, if we let this be a, x, and we let 2 be b, then we could just substitute all of this information into this formula so that we end up with x squared, because since that's our a, minus 2 times x times b, which is 2, plus b squared, so that's 2 squared, right? Which gives us x squared minus 4x plus 4. And now we have our perfect square trinomial. So basically, we got shortcuts. Honestly, whether you do the shortcut or not is up to you, because you very well could just use one of your methods, whether that be FOIL or box, and multiply it out that way as well. So where you have your first terms, x and x, right? So that's x squared. And then you have your outer. So x, and we'll call it negative 2, right? So that becomes negative 2x, right? And then we have our inner, which is negative 2 and x, so negative 2x again. And then finally, we have our last, negative 2 times negative 2, which is positive 4. And that will give us x squared minus 4x plus 4. we still end up with the same answer. But the key thing with perfect square trinomials is you can use this formula. I don't know if you prefer it. I don't know if you understand it. But what I want you to do is take a minute and try example 2. And we're going to go over this one in class. We're going to talk this through. The next type of perfect square trinomial is A plus B quantity squared. All right, when we have that squared, that just means A times B times A plus B. A plus B times A plus B. All right, and when we multiply these, this is our result here. A squared plus 2AB plus B squared. Now, if we take X to be A and 4 to be B, then this becomes X squared plus 2 times X times 4 plus 4 squared. If we simplify it, 2 times 4 is 8, so this becomes X squared plus 8X plus 4 squared. 4 times 4 is 16. And here's our answer. Now you choose a method, whether that be by using this formula we just went over, or one of your other methods we learned yesterday to complete this second example. And we're going to go over it in class. All right, now we're going to go through difference of squares. A difference of squares is when we have opposite here. We don't have A plus B times A plus B or A minus B times A minus B. We have A plus B times A minus B, which creates this difference of squares here. A squared minus B squared. All right, and how do we know that? Well, A plus B, and this is going to turn into negative B, so that'll be A plus negative B, which gives us A squared, AB, and then negative AB, and then negative B squared, if we're to fill this out. So it becomes A squared plus AB minus AB minus B squared. Notice how AB and negative AB are there. They cancel each other out, so all we're left with is A squared minus B squared. And that's where this formula comes from. So in our first example, we have 3t minus 4 times 3t plus 4. We could use this formula by saying 3t squared minus, so our A is 3t, our B is 4. So then this would be 4 squared. Leaving us an answer with, now we have to use our properties of exponents here. We have a product, so we're going to distribute the squared to the t and the 3. 3 squared is 9, t squared is t squared. So we leave it like that. Minus 16. And there's our answer. We're done with this problem. So maybe try the next one with in mind that x squared is a, or not x squared, a squared. A is x squared and b is 2y. And then finally, we're going to go through these cases in class.